Good morning. Good morning.
Good morning, sir.
Good morning. Sorry, due to some system problem, it has been late today, 10 minutes. My system hanged due to
Yes,
some
sir.
work I am doing. Okay. Now, we'll come back to the lesson. In last class, we had discussed the lab program, that is a leaky bucket algorithm. As I told you that the leaky bucket algorithm is a conjunction algorithm. Conjunction algorithm means where a packet cannot move freely and it will be in a conjunction, means due to that particular reason the packet may be dropped due to the inconsistency of the memory in a device or a router, or due to many packets flow in a irregular size. So for that, what we have taken one particular bucket concept, that is one bucket we have taken, that is in the form of a buffer. The device will have some space where the irregular packets is keep on coming. What do you mean by irregular packets? Why? Because it's today the world is of heterogeneous network. Different networks will have a different packet sizes, so but the packets will keep on coming. Assume your system needs a sustainable sequential traffic. So what you will do, that I have given an example of a six lane big highway is there. Suddenly it will comes to the one single road. So when it comes to suddenly one single road, someone should be there to manage that particular six lane big vehicles. Means six vehicles come to one particular vehicle should move. Means something should be there. That's a bottleneck thing I have explained you. Due to that particular reason, here also, what we will do in this particular land to control that six land, means a bulk of packets is coming. We will keep one particular space there as a bucket. So the bucket size will have some definite size, finite size will be there. The packet will come. We'll check the packet size whether it will fit into the bucket. If it is not fitting into the bucket, it will be told that the packet will not be fit into the bucket. It will be rejected. So then automatically the means the packet which will comes in that particular bucket size, less than that bucket size, it will be taken into the consideration. Once that has been taken, the bucket will have an outlet. That is, I've taken example of last class. I've taken example of a bathing. That is a jug will be there. So if 15 liters bucket is there, you can't use entire bucket for a bathing purpose. You will use a jug. Assume that 1 liter or 2 liters of a jug you are going to use. So 1 liter of water you will use at a time until all the 15 liters of the water, whatever there in a bucket, it should get completed. Then afterwards you will open a tap and you will fill up that particular. Like that same thing in computer networks. Once the packet has been filled in a bucket, the outlet will be open. Means outlet, assume that the outlet capacity will be of 250 bytes. If 2000 bytes of bucket is there, so continuously 250 bytes, 250 bytes only will be given out. Either whatever maybe the packet says, one packet is 1500 bytes, one packet is the 1200 bytes, one packet is 900 bytes. That's not at all a matter. Now from a bucket, the outlet will be there of 250 bytes. Only 250 bytes continuous traffic will be given out. So this is the advantage of an leaky bucket algorithm. I have sent a program also to you, and I have told what are the different variables which is needed in that particular thing. How that program. I hope that everyone you have executed. That particular program execute once. If any doubts is there, you can ask me. Um, 1 minute. Yeah, you can ask me. Now coming to the today's session, theoretical session. In a last class, we are discussing on a bridges concept. That is how a LAN switches or a routers will act as a bridges from one LAN to the another particular LAN. So how a packet from one LAN system will be moved via bridges to the other particular LAN systems, and how these bridges will make a role in that particular thing. We understand that bridges has one particular graph G, where it is a connected graph with cycles. and in that we are extracting a spanning tree of T as a subgraph of G, where all the vertices should be there in a spanning tree. So that's why we'll call it as a spanning tree. What is a spanning tree means? A spanning tree is a subgraph of a G where all the vertices or nodes of a G graph must be there in this particular tree. The tree itself is a non-cyclic. So here cycles will not be there. That means a packet cycling will be reduced and all vertices is connected in a different paths. So that also we have discussed. Now coming to the next thing, that is virtual LANs. The disadvantage in a bridges is that the scaling will become a problem, that each time once the new systems is added, entire network again you have to take, again you have to find a spanning trace like that. That is a disadvantage which we have seen. Now we'll go with the further virtual LANs. I will take that into the consideration. Share this. Sorry, 1 minute. Yeah, now coming to the virtual LANs. If the connection has been cut or you can't hear my voice, you can interrupt in between. Okay. Now, coming to the virtual LANs, what is this virtual LANs? How you can overcome from this virtual LANs the disadvantages of a bridges? See, the disadvantage of a bridges is the one important thing is scale, means scaling of a new systems. The another one is accommodating the heterogeneity. This is a very much important concept, which is that is Ethernet should be connected to Ethernet or Wi-Fi to Wi-Fi only. No combinations will be taken into the consideration. So now we will step into the virtual LAN for this solutions. Allow a single extended LAN to be partitioned into several logical LANs. Now the logical LANs will be taken into the concept. What do you mean by that? The entire LAN, whatever will be there, will be taken. In that, we are going to create an sub-logical LAN. So how a logical LAN will be created? Each VLAN is assigned an ID or a color. What do you mean by this? Each, for example, assume in practical, I will tell you. Now in our college, what happened in a BMSIT, different departments are there and different departments is having different labs are there, and each lab is having several systems. That systems are connected as a one LAN. Now these LANs will be has to be taken into the one particular thing. How these LANs will be taken as a one particular thing? How means each LAN will have its own identification, or a virtual LAN will be there. A color will be given to that particular LAN. How this will be taken? This will be taken in a segments of that particular LAN, and it will be inserted between that particular segments. Always this VLAN ID will be inserted into that particular segments, where when it comes to the particular LAN switch, there that switch will comes to know that this is belongs to this particular system. In other way, if I want to tell, for example, I'll tell you, you think like this. For example, when I'm sitting, assume that we are sitting in an MCA lab and we are browsing, or assume browsing, and there one person is there. For that particular person, means outside of a BMSIT person, he never knows the IP address what is there given to your system. That is, entire BMSIT will be identified by one particular router. That IP address is only known to that. What is that router? That's a bridge. That's only is known to that particular public person. So what he will do, BMSIT will send in a packet. When it comes to BMSIT, that particular bridge, that bridge will open this VLAN ID and it will identify that either for which particular LAN it belongs to. Assume that further in BMSIT, several LANs are there and several routers are there. So it will check which switch, internal switch, which switch it has to be sent. So that it will, that for that switch it will send. Then that switch will have an again virtual LAN ID which belongs to that particular LAN. Now in that LAN, all systems IDs will be there, or VLAN IDs will be there. So particular system will be identified. So in this way, partially solves the broadcast problem in the extended LAN. Now broadcast problems will not be there. Means sending a package to all the systems will not be there. Particular system, the particular packet will be gone. One attractive feature of VLANs is we can change the logical topology of the extended LAN without moving or changing anywhere or addresses. So this is another one important advantage. That is how you are making a clusters group of the systems, MCI department, IS department, CS department, like that. Logically, you are doing this. So logically means there is no need to shift the systems. That means you can combine IS and CS. You can make one particular LAN, and you can combine a MCA with the library. You can make one particular LAN, or a mechanical with electrical. You can make one particular. And like that, you keep immediately you move or you can change the particular VLAN addresses. So this is another advantage which is there in a thing. Now you see the one example here. When a frame from X arrives at a bridge 2, the bridge observes that it came in a port that was configured as being in a VLAN unread. So it inserts a VLAN header. Observe carefully. It inserts a VLAN header, that is VLAN ID, between the ether header and its payload. Ether header is separate. You know ether header. I will tell what we had discussed in preamble. Everything will be there, and payload will be there. Between that, a new thing will be inserted that is called as an VLAN ID, as I told in a previous slide example, how we're taking a BMSIT into the consideration. When the frame arrives at B1, you can see here. When a frame arrives at B1, it will only forward it to the port VLAN unread and not to VLAN 200. Now here for a B1, both the ports is accessible. Means whatever is there, it is accessible. Now, how this thing will be taken? Assume that if X arrives at a bridge, means when a frame arrives at a X at a bridge 2, so whatever is there, so assume this is a bridge 2. Now this means here what it will do in a VLAN unread, whatever is there, this particular virtual network, a header will be inserted between that. When the frame arrives at B1, means it will send to the B1. Now B1 will check which VLAN it belongs to. Means VLAN 100 only it belongs to. Why? Because VLAN 100 it has been set. Now it will send to VLAN 100, not to the next VLAN 200. So in this way, making the virtual LAN IDs inserted between the frames, this concept will be used. Now, so in this way, we will overcome the problem of the scaling as well as heterogeneous network also. Now here, how that will come out scaling and all, here nothing a problem that how many physical systems you are going to arrange. That means just you can extend the VLANs or VIDs to that particular systems. Now, coming to the next very important concept of this particular chapter, that is internet working. Now we'll step into internet working. What is this internet working? Today, the world is there with this particular internet. You know how internet in beginning classes also I told that as a network engineers, what is the importance of internet in a world today? Now, what is the internet actually? How this internet work has been taken into the considerations. Now, an arbitrary collection of networks interconnected to provide some sort of host-to-host packet delivery service is called as an internet work. That is, a host-to-host communication packet delivery should be done using a store and a forward method, whatever we had discussed. So that method will be used. Now here, interconnected heterogeneous networks will be there. Yeah, that is a very much important thing everyone should know. In a world, if I am connected with an internet, I can connect with a Wi-Fi, I can browse with on a mobile using a mobile communications, I can go with the Ethernet, either I can go with a token bus network, or either I can go with a token network, whatever a network we are going to use. So finally, we are connecting to the internet. Then your internet work should support these heterogeneous networks. Now you see in this particular figure here how a network 1 is there, which is of a wireless, and network 2 it is a ethernet network, and the network 3 it's a point to point network which is connected with a routers. So peer to peer network, again ethernet is there. Now, how these combinations of Ethernet will work and which protocol will, a common protocol will be there with all these particular different networks after above that, which will manage all the packets in and it will convey the informations which is coming from internal networks. So that we are going to see now. Now, IP. Now today the world depends on this particular protocol. Imagine a person who created this particular protocol in 1974 to this day. Now from that sense onwards, the entire network today the entire network today, the world is depending on this particular protocol. IP stands for the Internet Protocol, means it's a soul or a heart of entire Internet. When discussing with an TCP/IP architecture or on a suit, I told you that these IP is a one which is a brain or an heart of this entire network or backbone of this entire Internet. Key tool used means today to build scalable heterogeneous internetworks. Means this is a protocol by which heterogeneous networks or multiple adding of networks can be done. It runs on all the nodes in a collection of networks and defines the infrastructure that allows these nodes and networks to function as a logical internet work. This sentence today is very much important. What I will tell you, see, if you are which knows about all the networks that you have to keep in your mind. This IP protocol is the one today which knows all the networks today what is there in a
So your video froze for like 20 seconds. Like twice it happened.
what pa?
Your video froze for 20
You're
seconds. Your
you
voice
you
and
you're not
video.
getting
Now it's okay,
voice. You're
sir.
not getting.
Now I'm getting, sir.
One
Like
minute, just 1 minute. Now okay. Hello, hello,
now it's okay, sir.
hello.
Like hello, sir.
Ah,
Now it's okay. Like
tell
earlier
pa,
20
tell.
like 10 to 20 second it froze your audio and your video everything.
Sorry. Now it's okay.
Yes, sir. It's okay.
Hello.
Yes, sir. It's okay.
Yeah, yeah. Yeah. Mute it. I'll tell. Now, coming mute. Now coming to the IP protocol again. Now you see the below figure, which will tells the entire things on this particular sentence. Now this particular layer, whatever is there, you observe this net layer, whatever is there. That is one is 802.11. So which is one particular network of the type of Wi-Fi is there, and coming over here you can observe this is an Ethernet LAN, that is 803.1 which has been taken into the consideration, and coming to point network, what is there here. Now observe this different types of the networks is there here in this particular net layer. But here the IP protocol is all the same here. If H5 and H8 are the two hosts which it wants to communicate along with the routers R1, R2 and R3, observe carefully here. The whatever the H5 is there in assume the network of the Wi-Fi will packet will be sent to the router R1. Now what this router we will do, whatever a frame it's coming with the wireless, that frame will be taken and given to the IP protocol here. What IP protocol will do, it will converts that to the Ethernet frame, and again that Ethernet frame will be sent. Why? Because for this router, one connection is given as a Ethernet connection and one is a Wi-Fi. Now come back to the practical example. I will tell you. Now assume in our MCA department, when you observe the access points, observe the access point. That access point is connected with a Cat6 cable in turn with the particular other data center switch or some way. Assume. Now, the access point is having a Ethernet connection, but the laptop or a mobile which is connected to that access point is a wireless connection. Now, whatever a frame is going from either your mobile or on a laptop to that access point will goes there, and whatever frame will be there, that frame means in that particular access point means the wireless frame, whatever it will goes there, the IP protocol will be there in turn, which will convert that to the Ethernet frame, and through that Cat6 cable, the Ethernet frame will be moved. Access point to the data center or in a switch, that is a Ethernet connection, but laptop to the access point, that is a wireless connection. So your IP protocol which is there will knows all the types of networks, so it can convert from one frame to the another frame. So this is a one very much important concept which you have to know. Today, all the heterogeneous networks are in turn converted to one particular frame, means known with one particular packet only by this particular. Once it's converted to the CR, when Ethernet frame will come here, it will be converted to packet. This both TCPs knows only the language of packets, and this is the IP which is there, which will make this frame to the packet. And this IP knows that how many networks are there. Means it knows it's like a translator. It knows all the languages. So it knows to which language the translation should be done, where it will be acceptable by your transport layer, that is a TCP. So in this way, today the network is going to work. Now coming to the next slide. Yeah. IP service model. How the IP service will be given. There is a two parts in a IP service. What is that? Global addressing scheme is there. One is one very much important concept is there. What do you mean by this? Means identifying a particular device or a system in this entire internetwork. So how it will be identified? By the global addressing logical scheme, it will be identified. That is, each and every host in a network will be given one IP address, that is internet protocol address, that logical address, what we will call it as. So with that identification, the system will be identified by this particular protocol. Coming to next, datagram connections, means mode of delivery will be there. That is connectionless. We have discussed already connectionless and connection oriented. That is virtual circuit as well as datagram. Now, datagram is connectionless circuit. That is flooding. Means whatever may be the neighbors, asking a neighbors with a neighbors, another neighbors with that neighbors, another neighbors. Finally, it will goes to the destination. So best effort delivery, but unreliable service will be there. Packets are lost. What happens here in connectionless? There is no definite thing that packet can move in this direction, packet can move in that direction. I told you. So packet lost may be there, or packets are delivered with out of order also. Why? Because it never knows that either the destination is running or not. Duplicate copies of a packet will be there. Different path, means asking a neighbors, it will flooding through that flooding technology, it will keep on moving. Now, overall, these things I have told. Now you can ask me the question that, sir, then why connectionless it is using? Why not it can use in a virtual circuit, a definite path? So in this entire world and in this many of the close together of the connections, establishing a VC connection is very much difficult. It's not like one particular sector. Now, for a public internet, connectionless is the only way where it will work. So that peer to peer means asking us, you are my neighbor, you know this person, you are ask your neighbor. Your neighbor will be asked with that neighbor, and finally it will be asked. Finally, your destination will tell, yes, myself, I am so and so. So now again, return back reply will be there from your destination. So in all this sense, your IP protocol, what it should do, it should be capable of managing packet loss, delivering out of order or duplicate delivery, long time delay. If out of time goes, what to do? Your IP means IP protocol should service all these services should be given, and it's a duty of this IP protocol to manage or to send a packet from a host to the destination in a perfect route. If something happens, retransmission in charge should also be taken by your IP protocol. Coming to the next thing. Now, the IP packet frame, how the IP packet frame will be there. You can see here the figure, what it's showing from 32 bits, which has been taken, and how many 32 bits a header is there. You can count it here 1, 2, 3, 4, 5, 6. So, 632 bits. What do you mean by that? Means like this 6 is there. Means how many bytes here? 32 means 32 means hello? 32 means 32 bits means how many bytes? Listening? 32 bits means how many bytes? Hello? Hello? Listening everyone? Listening? Hello? Hello? Hello?
Sir,
Sir, four, sir.
4 bytes.
4, sir.
4 bytes, correct? Correct?
Yes, sir.
Hello?
Sir,
Yeah. So four bytes into 6 rows. 6 fours are 24. Hello? Correct? 24?
Yes, sir. Yes, sir.
24 bytes. Overall, sorry, how many will be there here? Four. Four will be there. How many are there here? One, two, three, 4, 5, 6. 6 fours are, yeah, 24 bytes. So total enter size of that particular thing will be there of that many bytes. Now, coming to one by one field, which we are going to discuss now. In exam, there will be a question like this. Explain IP packet format with a neat diagram. 8 marks a definite question. Almost all this question is there from last 2 to 3 years. Make a note of this. You have to write a figure. While writing a figure, the fields shouldn't be changed here. The sequence of fields and the bytes of that should be followed correctly. You don't think like that. I will write a format of that figure wherever I want fields. I will write. That will become a wrong. Now, first version will be there in a first row, that is 0 to 4 bytes, and 4 to 8 bytes header length will be mentioned. 8 to 16 bytes TOS is there. I will tell you that. Then 16 to 31 total length of the header will be there. Then identity will be given by 0 to 16 bytes, and the flags will be there from 16 to 19 bytes, and offset value will be set by 19 to 31. I'll tell you what is offset while doing a fragmentation. Now TTL, time to leave. So that will be there of 0 to 8 bytes, and which version of the protocol it is there, that is of 18 to 16 bytes it will be there. Then 16 to 31 bytes checksum is there. Now the IP address, the logical address which is of 32 bits, that is 192.16.10.1, what you will tell in your terms. So if you convert that, that will become say 32 bit. So 32-bit logical address will be there here, source address and a destination address. Both will be there here. And you can see the option variables are there. Optionally, it is going to use that particular fields, and padding of cells will also be there here for a padding variables. I'll tell you what is that. Now, this is the overall header information of that particular IP thing. While writing, this bytes mentioning is very much important. Now, coming to the version. Currently, there are two types of versions in IP, that is 4 or a 6, also called as IPv4 and IPv6. So header length, number of 32-bit words in a header. Usually 532-bit words with no options will be taken into the consideration always. 32-bit words, whatever is there, usually 5 will be taken. Sixth one is a optional. That's it. So only 5 will be taken into the consideration. 5 into 4, 5 fours are 20. So that will be taken into the consideration. Next, TOS. Type of service not widely used. Which type of service it is going to give? Synchronizing service or asynchronizing services it is going to give. This is optionally, means rarely it has been used field in a IP. Coming to the next, length, that is 16 bits. Number of bytes in this datagram including the header, means overall including the data, overall how much of bytes is there. So that number will be mentioned in this particular length. Why? Because when it's did a fragmentation, that length field will play an important role. Now, identity, that is 16 bits will be given, and flag bits, offset bits 16 bits used by fragmentation. What do you mean by a fragmentation? I will tell you. Next session is on a fragmentation, that is chopping off your packet into the parts. To identify that different chops, so that means parts that we are going to use an identity field and flags, and as well as an offset values. So based on that, the fragmentation will be done. Coming to the next, TTL, time to leave. The number of hops or routers this packet can travel. So how much time this particular, just 1 minute. Hey, yeah, sorry. Now, coming to TTL, it is a time to leave. That is, discard the looping packets, whatever is there. That means assume that one packet will comes and falls in a loop. How much time this should keep on looping? When the packet should die? I will tell you like this. I will give some 120 number. Each clock pulse, 120 will become 119, 119 will become 118, 118 will become 117, like that it will keep on down. Whenever it will become 0, then packet will die automatically. So that value, what you are giving, based on different versions of the IP and different networks, the TTL value will be given. Originally based on time, but change it to a hop count based. So how many hop counts are there? That many hops it has to read. Each router decrements it by 1. Discard the packet when it becomes 0. Default is 64 bits. Problems. What is there here? Setting it to high, the packet will loop a lot. Means whatever number of hops is more, if you fix the value to the more, the looping will become more. Setting it too low, the packet will not reach the destination. So you have to, means setting that particular value according to the dynamic hops is the one challenge which the IP protocol will be taken into the consideration. Now coming to the next thing, that is a protocol. Now protocol is demux. What is this demux key will be there here? That is multiplexing and a demultiplexing concept what we had discussed in a earlier. So TCP6 and UDP 17 as a demux key, it will be there in a protocol. Then checksum value. What is the checksum of the particular header? Means checking whether this particular packet is correct or not. So that thing will be there. Then destination address and the source address is of 32 bits, as I told you that the key of a datagram delivery. A connectionless delivery you are doing, keep in your mind, in a connectionless delivery, identifying a person is very much important. The identification should be of a unique. Otherwise, there will be a clash. So that's why even university number, how in entire VTU university, your number is a unique number. So easily it can be tracked. Then same concept will be adapted here, that IP address is a unique in entire internet work that can be identified easily. So every packet contains a full destination address. Forwarding routing decisions are made at each router based on these addresses. The source address is for the destination to know the sender and if it wants to reply to it. Means why source address should be there here? Always the destination should know that from which address this particular packet is coming. So in this way, this for this question, explain the IP packet format with a neat diagram for this. Like this, all the fields you have to explain. The next concept is the one that is IP fragmentation and reassembly, which we'll discuss in a next coming class. Now, I will stop sharing of this particular slide just now. Yeah. Stop sharing. I'll close this. Yeah, now I think now you have understood what is the concept of VLAN today's session and how you can overcome with an VLAN and how VLAN ID will be used, and then we gone with an internet work. So how this today the world with heterogeneous networks will be handling as a single internet work. How the IP protocol, which is a brain or a backbone of this entire internet work, managing, connecting different types of heterogeneous networks, converting a frame to a packet based on the networks. And in further, when discussing, still we are discussing on a IP protocol itself. We will discuss a fragmentation. After fragmentation, we'll discuss how a routing will be done. In advanced concepts of IP protocol, how ICMP and how the IP addresses and how a different class of IP addresses will be allocated and how subnetworking will be done. Everything we've discussed. Entire chapter is based on this particular IP protocol here onwards. Okay. 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 Any doubts are there? You can discuss. Any doubts? Any doubts? Hello? Any doubts? Any
No, sir.
doubts? Okay, pa. Okay, tomorrow, Thursday, right? Class will
Yes,
be
sir.
taken at 2 o'clock.
Okay, sir.
2 o'clock, I will take a class. In that class, we'll discuss. And today night, evening, I will launch the forum, Google forum, and I will send you the link. Tomorrow until evening, time will be there for a quiz. As I told you that 10 to 15 questions will be there. You have to answer that particular questions and it will be considered as a assignment. Okay. So thank you very much.
Thank you, sir.
Bye. Thank you. Bye. Bye. Bye.